Hello and welcome back. Let us try to understand correlation coefficient. We have understood covariance, and in that covariance, we can understand the direction, that whether it is positive or negative, but we cannot measure the strength. But correlation coefficient can give you the direction and strength both, because we are actually standardizing the covariance and trying to find values, trying to find a number which is between -1 and +1. So when you calculate correlation coefficient between two variables, two numerical variables, the value is always going to be between -1 and +1. If the value is close to -1, there is strong negative relationship. The value is close to +1, there is strong positive relationship. If value is close to 0, there is no relationship or weak relationship. So there are different ways of calculating the correlation. The Pearson correlation, Spearman correlation. We'll see all those in a moment. Let us take an example and try to calculate correlation coefficient. So here the correlation coefficient formula is covariance divided by standard deviation of x into standard deviation of y. Basically, we are standardizing the covariance score and calculating the correlation that actually falls between -1 and +1. So the correlation between experience and salary is 0.95. The correlation between experience and aggressive behavior is negative 0.79, and the experience and active score is negative 0.78. So when you look at these numbers, right, you can say the experience and salary are strongly positively related, and experience and aggressive behavior are strongly negatively related, because it is close to 1, not close to 0, right? Even the experience and activity score also strongly negatively correlated. That means with the experience growing, the person's aggressive behavior is definitely reducing. With the experience growing, the person's participating in different activities also reducing. So you can clearly see the relationship with the numbers when you calculated correlation coefficient. But when you calculated covariance, the numbers are big and small and you don't know what's happening there, because it is just giving you the direction but not the strength. Here you are getting the direction with the sign, the negative and positive sign, and the strength with the number. The number is also between -1 and +1. So you can clearly see what's happening with the relationship with the two variables there. So with this correlation coefficient, you can actually identify the important features that can predict the target variable. If you have to build a model which need to predict salary, and there are different numerical variables in your data set, and you want to identify which feature is important, you can calculate correlation between salary and the other features and understand. This is individually for which one column to the target variable, or one variable to one input variable to target variable relationship, but all together the effect may be a bit different. In multiple linear regression, we have seen that a little bit, right? So there are some bullet points here which we need to remember. Correlation does not have units. The covariance always has units, because you are not standardizing. So numerator has got the x minus x bar into y minus y bar, but in correlation you have got the divided by sigma of x1, the standard deviation of x1 and standard deviation of x2. So the numerators units and denominators units will get cancelled, and you will not have any units for this. It is just a number between -1 and 1. If it is close to 1, it is strongly positive relationship. If it is close to -1, strongly negative relationship. Correlation isn't affected by center. Even if the mean changes, right, when you add more values or remove some values, correlation generally will not get affected. Okay, so if you look at the heat map for the correlation, you can clearly see that the diagonal values are all 1, because you are trying to calculate correlation between experience and experience, salary and salary, aggressive behavior and aggressive behavior. With the same column in itself, always the correlation is going to be 1, because the values strictly increase. Here 1, there 1, here 2, there 2, like that. So it is 1. This is also a symmetric matrix. See this? The lower triangular matrix values and upper triangular matrix values are same. If you fold, right? If you fold the paper like this, right, you get You get all the all the values here are equal to all the values which are present in this place. So that is called as symmetric matrix. If it is a square matrix like this, and if you fold it like this, right, all the values lying in this place and all the values lying in this place are going to be same. That is called as symmetric matrix. The diagonal values are all 1, right? So why is that happening? Because experience to experience and salary to experience here, and again the salary to experience here, right? This value and this value are same, and again aggressive behavior to experience, and again experience to aggressive behavior, this value and this value are same. If you look at the scale, right, all negative values have got green and all positive values have got the red. So the values are the colors are moving towards red, you can say that the relationship is strong. If the colors are moving towards green, you can say the relationship is weak or negatively strong. Okay, so here with the visualization you can actually understand things clearly than the numerical values. So let us try to jump into the code and see how exactly you can generate this this code block, this whatever the heat map. Okay, so here individually calculated the correlation between one series object and the other series object, because again series object has got a method called CORR, which actually takes another series object and tries to calculate the experience and salary. We passed and calculated the correlation, experience and aggressive behavior, experience and activity score. And if you want to calculate correlation between each variable and other variable, or each feature and other feature, you can just say the data frame dot CORR, like in covariance, data frame dot COV we did there. So it actually gives you the numbers like that, but when you look at the numbers, they are going to be confusing. See, the diagonal values are all 1, and the lower triangular and upper triangular matrix are same. It's called as symmetric matrix. And here, to generate the heat map, the same thing we are going to do, right? I have taken the RC parameter and then passed a parameter saying that padding is 60, because these X values, the X labels are actually getting merged into this, right? And then I have used a heat map and passed many parameters there. The most important one is the correlation matrix here, and then the color map. Okay, and if you want to take out this clip-on false, right? If you take clip-on false, what happens? Let us see. Right? You see this? The the first row and the top row are getting chopped off. If you actually comment out this parameter and the margin padding, what happens? Let us see. So if you take out, right, if you actually have that false, right, it is going to generate, and that generate complete boxes there. And like that, right, we have other parameters also you can play with. I have given the Vmin and Vmax, which actually going to be taken by the scale here. The minimum is -1 and maximum is +1, because the correlation coefficient is always going to be between -1 and +1. We need to give the colors there. And line width is 0.5, which is actually the line width here, the the padding between one square and the other square. The X ticker labels, you wanted to show X ticker labels or not. And then how many decimals you wanted to show. Format FMT is equal to 0.3f, that means it shows 3 decimal points. If you take 2f, if you actually put 2f there, it's going to show you only 2 decimal points there. Okay, so I just showed 3 decimal points there. Like that, you can play with this, right? Annotation is needed or not. When you put NT is equal to true, it's going to populate all these the correlation scores here. So so you can play with the code and generate whatever you want. So that's about the correlation coefficient and how exactly it shows you the strength and direction between two variables. Thank you.